Welcome to Guruvira Textile and Fashion Technology Tutorials.
Hi friends, this video clip give you brief explanation on silk fiber. As discussed in the previous classes, this silk fiber classified under the category natural fiber because it is produced from animal, that is insect. It is an extruded filament fiber and it is a protein fiber, and the history behind the existence of the silk fiber is a long story. It starts from China. The origin of silk fiber, its development, its growth and its transformation to the rest of the world is a big story. That is not required here. Just consider that China is the origin of the silk industry since last 8,000 to 10,000 years back. That is a BC back century. And there are two types of silk produced globally. That is, one is wild silk and second one is cultivated silk. Wild silk, the process involved and quality achieved in both the wild silk and cultivated silk is different. The quality achieved in the cultivated silk compared to wild silk is better, and commercially also better. But the process involved in cultivated silk, that is in sericulture, that is very easier than wild silk, because in the wild silk the production of cocoon or whatever the natural process is there, the production from the mouth is very tough, and also the production of quality, the production of the cocoon, the formation of cocoon is very not of good in nature. Okay, now coming to China, the global production. Now at present 54% of the global production is going to China, and second 14 to 15% going to India, and the rest of the percentage of the global production of the silk fiber to the other Uzbekistan, Iran, Brazil and other countries. Okay, now here silk fiber is a protein fiber. What is that protein? Fibroin. Fibroin is a protein, it is a substance. Fibroin is a substance present in the silk fiber. How the cellulose, the substance present in the cotton, keratin substance present in the wool, like that fibroin, the protein substance present in the silk fiber. Okay, and the sericulture of this silk is important to know. We will see how the silk is formed by the animal. There is a simple cycle is there. Simple cycle means that is not man-made cycle. That is a natural process of the animal, insect. Okay, how the cell sericulture takes place, the process, how the moth produces the eggs, what are the type cycle is there, natural process. We will see. First, see, there is a moth. Okay, it's like butterfly. It's like a butterfly. It seems like a butterfly, but it's not a butterfly. It is a moth. And also, it is an insect. The insect. At its mode of metamorphosis time, it lays the egg. It lays the egg. Okay. In sericulture, that is right, the silk farmer or systematically this harvesting is done by the farmer systematically, okay, scientifically. These eggs are laid by this moth. Okay, these eggs are then these eggs are after sometimes egg hatching takes place and egg hatches. Okay, egg hatches. In this egg hatches, the inside, the next generation of this moth, that is in the form of small ant. It's not very small, tiny ant. It's coming out. Tiny ant. It's coming out. Okay, this is a tiny ant. It's coming out. Egg hatches, and inside the tiny ant of this moth, the next generation coming out. This is called this is happening in 3 to 4 days. And from egg hatch to this stage, this is the first molt. This first molten stage of this next generation of this moth. I'm not using any name here. Just I'm saying this is an insect, the next generation of this insect. Okay, this is in a teeny form. Okay, say you can say next, and again it develops. Okay, develop means its body grows. Its body grows day by day and reaching second molten stage. Molten stage in 3 to 4 days. Okay, like that it is coming to third stage. Third molten stage. Molten stage in 3 to 4 days. Like that 4 times molten stage goes under 4 molten stages. The body grows rapidly day by day in a very speed, like small minute ant size of the body becoming growing day by day rapidly. Okay, fourth molten stage. Fourth molten stage. Okay, how here when immediately after this moth, now I am using larvae. Now I am using the word larvae. This larvae immediately after coming out from the egg starts eating the mulberry leaves. Okay, the silk farmer feeding the mulberry leaves to enhance the growth of this larvae. Okay, see, to produce 3 to 4 kg of silk, the consumption of mulberry leaves is about 100 to 105 kgs. To produce 3 to 4 kg pure silk, the silk farmer has to feed mulberry leaves of about minimum 100 kgs. Consider continuous feeding. This larvae, the next generation of this moth larvae eats continuously, eat. The body grows well developed. At each 4 stage, it will feed. This is feeding time. This is eating time. After that, the final stage, the final larvae. Okay, the final larvae becomes bigger. Final stage of this larvae. Here, this is the final stage of the worm, silkworm, grown worm. This is a silkworm. Larvae, silkworm. It is a final built up. Now it is ready to spin the filament. How it is spinning? This larvae, the silkworm, having 2 spinnerets at its mouth, and these spinnerets are called brain. Okay, the fibroin, the liquid form of the fibroin produced in the gland of this larvae, silkworm, are forcefully extruded out through the spinneret, that is brains. Okay, in the form of filament. The fibroin, the liquid form of the protein solution, is forcefully extruded through this spinneret called brains. Okay, and whatever coming out, the liquid form of the fibroin protein, when it comes and get in contact with the air, it gets hardened. Okay, it gets hardened. Whatever filament is coming out, it gets hardened. And one more point here is, there are 2 spinnerets, as 2 brains are there. A pair of filament is coming out. 2 filaments are coming out. And also there is another substance in there, and that another substance is called sericin. This here, fibroin. Okay, this sericin is a gummy-like substance. Makes these 2 fibroin filaments stick together. Makes these 2 filaments stick to each other and feel like very hard. Because of this sericin, gummy substance, these 2 filaments are sticking together and getting hard feel. See, this sericin also a protein. Fibroin also protein fiber. 20% of this filament is having fibroin. Okay, now see the next, whatever this thing, how it is. Is it not simply throwing out the filament from its mouth. But in the sericulture farm, the silkworm farmer is keeping this all thousands of these eggs, thousands not 10,000, many of eggs is in the frames, cocoon frames, that is feeding frames. Okay, and in this cocooning frame, this is called cocooning frame. Cocooning frame. Whatever the larvae, the silkworm finally grows silkworm, when time has come for excretion of the filament, this all hundred thousands of silkworm starts producing cocoons. How it's producing cocoons? This silkworm larvae, while it's extruding, it is taking the filament, it's taking the dried hardened filament around its body. Around its body. Here, the filament, this is a larvae, silkworm. It is taking around its body. Okay? It is rotating its mouth, and it itself encaved itself, the body, the larvae silkworm itself encaved within this ball. The ball is called cocoon. This ball is called cocoon. Inside, silkworm is dedicating itself. I'm using the word dedicating. It's dedicating itself to form a cocoon for the use of humans. For the man, it's dedicating its life. Okay? Here, the thing is, the continuous filament, it is revolving around its body. Okay, taking the filaments, making more revolving around its and make the ball. Okay, continuous filament, because of continuous filament, it's making. How much length it is making filament? In 3 to 4 days, it's making a mile of filament. A mile of filament produced in 3 to 4 days. Within 3 to 4 days, a mile length of filament is produced by a single larvae. And also, it's encaved itself, within itself. This is important. When the cocoon gets its weight, when the silk farmer feels that, oh, cocoon is achieved its weight, then what he will do? He will kill this inside larvae. Inside, he will kill. Don't think he will kill means not other words, it's like he will kill because he wants filament. The main rearing of the silkworms, the formula of sericulture is to get this filament. Inside the silkworm, now I am using other word, pupae. This pupae, when this silkworm converting and becoming a pupae, when it time comes to come out, he will kill, the silk farmer will kill. Okay, but he will not kill all percentage of whole 100% of what he has reared, but some amount of, he will allow some amount of pupae to come out, to start to produce the next generation silk moths. Okay, he will allow some cocoons for the next generations or to have next eggs. But most of the other are killed. How this inside pupae is killed? All the cocoons are soaked in a boiled water. All cocoons are soaked in the boiled water. In the boiled water, inside pupae is killed. And also because of the boiled water, whatever the sericin gummy substance is there, because of the sericin, the cocoon surface gets hardened, and also the surface because also there is some amount of minerals in there. Okay, to remove those some amount of minerals and to make the cocoon softer so that he can unwound the filament. Whatever the miles of filament produced by the silkworm, that the silk farmer wants to unwound and reel it without breaking up the filament. How much he is efficient in getting the whole miles of filament, that much of qualitative silk fabric he can produce. Okay, if there is a broken, if sericin amount is more, if the quality of cocoon is not so good, if the larvae is not produced properly, the cocoon, then quality will be less. And also when he soaks the cocoons in the boiled water, inside pupae is killed and the cocoon gets softer and easy to unwound the filament. Okay, so some amount he will keep, some amount of cocoons he will keep for to produce or to have eggs for the next season, for next rearing. Okay, I hope you understood. This is a cycle process. This is a cycle. This is how the silk is produced. Now, the next is I'm going to discuss briefly. See, the next will go for the properties of silk fiber. Properties. In our previous classes, I discussed the properties of cotton wool fibers. What are those physical properties? All textile fibers have common properties. Color. First one, color. What is the color? What is the color of silk? It is sometimes it is yellowish or brown or grey. Okay. Or better is white. Better is pure white. To produce pure white, it's very tough. It's a qualitative color. Next. What is next? Strength, tenacity. What is the tenacity of this fiber? Compared to cotton, compared to wool. In the natural fibers, this silk is the strongest fiber. It is having tenacity of 3.5 grams per denier. Good tenacity. Okay. And specific density. Specific density. You see, where specific density is only 1.25 to 1.35. Okay. See, weight of the silk fabric compared to wool, compared to cotton, hope is lightly. The weight of the fabric, weight of the garment, weight of the fibers depend upon the specific gravity. Cotton is 1.54. Okay. Here 1.5, almost nearer. It is lesser than the cotton. It can be more. Elastic also strength. Is it good? Then is it? What is elasticity? Silk will not elongate, less or poor. Okay, poor in elasticity. Then elongation, that is also poor. Elongation, poor. It is not elongate. It will elongate, but recurve will be not there, and it will broke if it is elongate more. It also poor. Now, luster. See, in natural fibers, luster, silk is a queen of the textile industry. Cotton is a king of the textile industry. Why is it a queen? Silk is queen. Its luster is very high. It's more like synthetic fibers, polyester, nylon. It is competing. The luster of the silk is a natural God gifted because the cross-sectional area of this silk fiber is it's like triangle. Okay, it's having 3 sides and 3 curved faces. Because of this triangle, the light reflects. This reflection of light makes chum. It will glow. It will reflect. It shine. Okay, and also if it's the silk produces high quality silk, will produce very pure white. That is even pure white and shiny. It's a very beautiful silk. The garments made beautiful. Okay, this is luster super. This luster of the silk is very super. Let's come to moisture reading. What is moisture reading? Moisture reading also moderate. Moisture reading is 11%. See, moisture here 11% means definitely it's having space, air space or some space available inside the morphology of the silk fiber. It allows dye to enter this fiber. Means dye ability of silk fiber is very good. Okay, wool is having 13%. It's 11%. Moisturizing. The silk fibers can be used for wet processing, can be subjected to wet processing, and it's a dye ability. Dye fiber ability is very good, but because of the hydrogen bond, the percentage of hydrogen bond present in this morphology between the polymer chains or between the fibrin substances more, because of the bonding, high bonding in the polymerization, the strength is more. Okay, understand? Strength is more, and moisture again is the dye ability. Okay, next, what is our why this we have to? These are the character properties are required to spin to judge the quality of the final product used by the consumers. Next, chemical properties. Can we think about chemical properties? What are the chemical properties? The common properties everybody talks in textile industries are first one, effect of acids. Effect of acids. How it behaves, silk fiber, how it behaves when it comes into contact with acid. Silk fiber will resist mineral acid and some weak acids only. But the highly concentrated acids, it will not resist, it will dissolve. The silk fiber will dissolve in highly concentrated acid like H2SO4, sulfuric acid, highly concentrated acid, it will dissolve, it will not resist, only resist. So it will damage, it will decompose in high concentrated acid. But small weak acids, mineral acids, it can withstand. It is also little bit. Okay, so wet processing or dyeing process to be considered in this case. Now what about alkalis? What about alkalis? Alkalis also it will not resist highly concentrated alkalis. It is a weaker. High concentrated alkalis make fiber weaker. Okay. Next, what about light? Longer exposure to the sunlight, the fiber started to get decomposed slowly. So the product of silk fibers to be kept in a keep or store in a cool and better, not high warm, but longer period of exposure to sunlight may change in the properties of the fibers. What about insects? Mildew, bacteria, insects, mildew insects. You see, longer storage of this product, the place may be damaged by this mildews. Okay. Rest other some bacterial effects is common. Any product you keep for longer time, even we sit for 10 days in one place, mildews will attack us. Okay, like that. No need to think about this. Now, see, individuals, silk fiber individuals. Now it's using for shirting, it uses for making ties, and this silk fiber used for lining. And especially in India, silk fibers are used for the grand sarees, Banaras sarees, Kanchivaram sarees, the highly celebrated functions, marriages and other functions. These are grand. It's a grand fabric. It's a silk is a queen of the industry and also a grand fiber, a rich fiber and having demand in textile industry. It's some kind of respectable fiber. Okay, and this. And nowadays, the silk fibers are using for many other areas, like it's making in the industry. It's used for making parachutes, and some other industrial applications are there. Okay, and also blending of fibers. Not filament is got blended. Silk is used as a spun fiber, spun yarn, or thrown yarn. Thrown yarn. Thrown yarn is having continuous filament. Spun yarn is staple. The filaments are cut into staple, small like cotton. So blend with the fibers. It can be blend with the other. Silk is blend with the polyester, and silk is blend with the other. It depends upon the end use. The blending topic we will take in future classes. Okay. Now is individual fiber studies going on. Okay, but strength wise, thrown yarn is stronger than spun yarn, even though it is twisted by in the spinning wheel, but the thrown yarn is stronger. Okay. See, silk fiber, hope you understood the small, our serial is a small topic, not covered many more points. Basic idea of the silk fiber. The dyeing of the silk fiber and spinning of the silk fiber will take in this fiber. Hope you understand. Okay, as I am repeating, 54% of the global production is taking place in China. China is the origin of the silk fiber. Next to China is India. In India, the states like Karnataka, Tamil Nadu, Andhra Pradesh, West Bengal, Kashmir. These are the main states in India. Okay, these are main states in India. Now technologies developed a lot regarding sericulture, regarding automation in the reeling, how without to increase the efficiency of the reeling, to increase the efficiency of the production. And also price, silk price is always high. Okay, hope you understood. Please subscribe my channel, like it, share it and forward to your friend who are interested. Thank you.
Please subscribe to this channel. Click the icon bell to get the notification. Like it, share it. Thank you very much for watching this video.